And good afternoon, everybody. Here are some more examples of simplifying trigonometric expressions. And these ones are going to focus on using even and odd properties of the trigonometric identities. And here's the first one. So number 23 from the textbook, sine of a negative x. So one of the goals when you're working with identities is to try to get your angle statement simplified to a positive angle statement by using even and odd properties. So if you have a negative angle, then you can use those properties to switch it to a positive angle. So one of the trig identities for sine is that sine is odd, which means the negative can come out to the front. So we're going to say sine of a negative x is identical to sine of a positive x with a negative in front, multiplied by cotangent is also odd, so the negative will come out to the front. And we know that a negative times a negative is just going to be a positive, so we can just call it sine of x multiplied by cotangent of x. And now we can use some of our other known identities. We know that cotangent is cosine over sine. And now we have a situation where we have a factor of sine up top and a common factor of sine down bottom. So common factors cancel. Sine divided by sine is just 1. So we are just left with cosine. And that's going to be your simplified form. And here is number 25. So again, we have a positive angle y, but we also have a negative angle y. You can't have two different angle arguments. They either both have to be negative or they both have to be positive. Usually people prefer to work with the positive angle, so we're going to use our odd property of sine to take that negative out. So we're going to say we have sine of y, and we'll take the negative out, put it in front. And now we have sine of y minus sine of y, and that's going to be 0. Anything minus itself is 0. So final answer for this one is 0. And here's number 27. So again, first move, you want to change all of your angle statements. So sine of x we'll leave alone, that will stay up top. Cosine of a negative x, we know cosine's even, so cosine of a negative x is identical to just cosine of a positive x. So cosine will just become cosine positive x, plus the negative we'll take out of the sine, so negative sine of a positive angle, and cosine of a positive angle. So now all of our angle arguments are positive. And now we have common denominators. Notice we have a denominator of cosine and another denominator of cosine. To add fractions, you always need common denominators, so we do have a common denominator. So we can go ahead and say this is sine of x up top plus or minus sine of x for the other numerator, all over common denominator cosine, and sine up top minus another sine up top, that's going to be 0. And 0 divided by anything is always 0. So final answer will be 0. And question number 29. So again, we have a negative angle, negative alpha, so we're going to bring that out to the front. So we'll say 1 plus sine of alpha is in the first parentheses, and then 1 minus sine of alpha, because we're going to bring the negative out to the front, is in the second set of parentheses. And from here we can just go ahead and distribute and multiply. So 1 times 1 should get us 1. 1 multiplied by negative sign is negative sign. Sign multiplied by positive 1 is positive sign. And sine times sine, we know that's going to be sine squared, but we have a positive and a negative. So a positive times a negative is a negative, and it's going to be sine squared. And your two middle terms will cancel. Negative sign and positive sign will be 0. So you're left with 1 minus sine squared. And here's that trick that we've seen in the past. This has some of the components of the original Pythagorean identity. So we know sine squared plus cosine squared is always 1. So to get it to look like what we have, if we brought our sine squared over, you're going to get a new equation that says that cosine squared is the same thing or identical to 1 minus sine squared. So 1 minus sine squared can be replaced by cosine squared. So we'll say 1 minus sine squared in our problem over here on the right. 1 minus sine squared is just identical to cosine squared. And that should be number 29. And here I believe this is the last one for this problem set. So number 31, the negative on the sine function, that can come up to the front. So we'll call that negative sine of a positive beta multiplied by cosine. The cosine function is even, so the negative is not going to come out to the front. It's just going to be switched to a positive angle statement. So cosine of beta multiplied by cosecant beta. And now that all of our angle statements match, now we can use the other identities. So cosecant, we know cosecant is 1 over sine. So let's say this is negative sine beta multiplied by cosine beta multiplied by cosecant. We can switch that to 1 over sine. And this is going to allow your sines to cancel because you have a sine beta down bottom, so, and a sine beta up top. So sine beta divided by sine beta, that's going to be 1, so you're left with a negative cosine beta. And that should be the final answer for number 31. So there's your examples for problem set. I believe that was 23 through 32 out of the textbook.